Hi everyone, how are you guys doing? Welcome to my channel Bits and Bytes. In today's session, we will be discussing about Ethernet header and its fields. So let's get started. So what you see now is a short animation showing fields of a Ethernet header. So you can visualize my intent to understand how it works. Imagine Ethernet header like a goods train carrying multiple cargo containers of different sizes. And the track on which the train moves is our Ethernet network. So we have several fields like preamble 7 bytes followed by SFD 1 byte, then our source and destination MAC address 6 bytes each, type 2 bytes, and the data field where the actual data resides 46 to 1500 bytes, and then the CRC 4 bytes. So let's look at each of these fields in the coming slides. The first field is the preamble. Ethernet frame starts with a 7-byte preamble. Each byte alternatively stores ones and zeros to make the pattern 10101010. It helps the receiver to know that the flow is actual data and not some random noise in the transmission. Preamble is used to allow sender and receiver to establish bit level clock synchronization. When a device receives 7 continuous bytes of the same pattern 10101010, it assumes that the incoming data is an Ethernet frame and it locks the incoming bit stream. So it serves the purpose of clock sync between the source and destination, and also lets the receiver that it's actual data and not some random noise in the transmission. SFT, start of T limiter. This is 1 byte field which is always set to 10101011. The SFT at the end of the preamble warns when the real data is about to start. So this field is similar to preamble. However, we only have one occurrence of pattern 10101011, and the last bit is always 1. So the time sync has to happen before this byte uh, is received, and it signals receiver that the data transmission is about to start. Then we have destination MAC address. This is 6 bytes long. It contains the MAC address of the destination device. Source MAC address, it contains the MAC address of the source device. Next we have is type. This field is 2 bytes long. It stores information about the protocol of the upper layer. It carries ether type, which tells what type of a packet it carries. If the type field has a value 0x800 in hex, the frame is carrying the data of IPv4 protocol. If it has a value of x0x806, the frame is carrying an R packet. Every layer has an ether type field which tells what protocol packet it's carrying. Data and pad. This is the field which carries the actual data from the upper layers. It has a size limit of 46 bytes minimum and 1500 bytes maximum. If the data is less than the required minimum, padding is added, and if it is more than the maximum limit, extra data gets packed in the next packet. It's like if the container is not filled, add padding to fill it up, and if it's already filled up, then the extra data goes into the next container. FCS, frame check sequence. This field is of 4 bytes used to check if the received frame is corrupted. This is very important, right? So the sender device takes all the fields of the frame except the FCS field and runs them through a CRC algorithm. This generates a 4-byte value that gets saved in the FCS field. Now the receiver, once the frame is received on the receiver end, it runs the same algorithm on all the fields except the FCS and generates a value. If the value matches the value stored in the received frame FCS, the frame is considered good and processes it. Else, the frame is considered bad, corrupt, and it's discarded. I hope the session was informative. Thank you so much for watching. Have a nice day.